All right, so second objective is going to talk about shape of the sampling distribution of a sample count. First off, please go to the activity on Elastic, talking about sampling distribution of a sample count and approximating to a normal distribution. All right, so make sure you take a look at that one. Okay, and when you come back, we'll talk about the large counts condition. So the large counts condition is what you should have concluded, in your activity. So suppose X is the number of successes in a random sample of size N from a population with a proportion of success P. Then this large counts condition says that the distribution of X will be approximately normal. This idea being normal if this occurs. If N times P is at least 10, and if N times 1 minus P is at least 10. Again, N times P is your expected number of successes. N times 1 minus P is your expected number of failures. You need to have at least 10 of each. If you don't have at least 10 of each, then there's no point in doing the problem, because say your NP was not at least 10, then we're not thinking we're going to be successful very often. We're going to fail a lot. So, there'd be no point of doing this problem, okay, with a normal distribution. So again, the large counts condition allows us to say whether we are approximately normal or not. And this is going to help us use the probability stats applet to find probabilities. Okay. Okie doke. So here we go. It says, suppose that 12% of teens in a large city have a debit card. Let X equal the number of teens with a debit card in a random sample of 500 teens from the city. Would it be appropriate to use a normal distribution to model the sampling distribution of X? Justify your answer. So in order to see if it's going to be normal, we have to use the large counts condition. So the large counts condition first starts off with N times P. So we have to identify what N is. N is your sample size, 500. P is your proportion. That's the percentage they give you of 0.12. So we'll do N times P. 500 times 0.12 is 60. That is at least 10. So you're good. Now we have to do N times 1 minus P. 500 times 1 minus 0.12. And that's 440, which is also at least 10. Because both of these numbers are at least 10, we can say that this situation is approximately normal. And if we wanted to do a problem involving a probability, we could use a normal distribution to help us do that. Now, I do want to draw your attention right here. If you want to try to save yourself time in typing in calculator stuff, so these two numbers here, they should add up to your sample size. So be aware of that. That once you find the first one, you can just take the sample size minus the first one to get the second number. But it's up to you. I mean, you're still going to use a calculator, I guess. So, okay. So there we go. All right. Large counts condition. Okay. Next objective and most important objective coming up.